Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey, you just found another episode of the Digital Enterprise Society podcast. Thank you so much for coming along on the journey of this show that we started over 2 years ago, and we designed it to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show each and every week with the amazing Craig Brown. Hey, Craig, how are you today?
I'm great, Thom, and I'm not amazing, but thanks. And we're gonna change again today. We're gonna go back and talk a bit about supply chains. We haven't been talking about that recently, and especially in this day and age with the challenges of the pandemic. It's in the news all the time. My goodness, look how screwed up the supply chain is for whatever, microchips or something else. So anyways, that's what we're going to talk about today. So here we go.
I think it's going to be fun. And every single week, Craig and I try to bring to all of you who are listening very interesting interviews and other ideas to help everyone enhance and grow their careers. And today we have with us Jennifer Herron. She is the founder and CEO of Action Engineering. And what she does is she helps manufacturers build resilient futures centered on connected, trusted models. They take 2D drawing-based processes and help people realize the value by using 3D models. Basically, taking it from paper to computer-based models. Hey, Jennifer, welcome to the show.
Thanks, Thom.
So, Jennifer, give us your background. How did you get started in your career and what led you to Action Engineering?
Well, my bachelor's degree is in mechanical engineering, and I also have a master's degree in computer engineering. Sprinkled in there's almost a theater minor, by the way, and I did a whole bunch of dance and musical theater in high school, so a little bit of a performance stunt as well.
So most mechanical engineers did musical theater, isn't that correct?
I think
probably not.
Yeah, but they should. I mean, why not? Yeah, so I'm a little bit funky in that way. But my first career was in spacecraft design, and I did discovery missions, New Frontier missions that NASA contracted, and did things like make latches and hinges and stuff for spaceships that collected space dust.
Well, that's cool.
Yeah.
I'm an aerospace engineer, and by the way, also did my thing in music for a while. And I contend some of the most innovative engineers are really pretty good musicians.
Yeah.
It's the math. If you're wondering what's common, it's the math. In order to do music you got to do math well. So, but at least that's what I learned over the years. So, So Jennifer, welcome to the show. Now, you and I could talk about spacecraft crap for several hours, but that's not what our audience wants to hear about. And so you started there and I jumped in. You ended up with Action Engineering, and describe for us that and why you founded it.
Yeah, sure. Well, from spacecraft, I went to robotics, and I spent about 15 years building a bunch of mechanisms and structures and things like that, and did it in a whole bunch of different CAD systems. So I used PTC products, Siemens products, Dassault products, and I thought, this is really interesting. I know how to do the same thing in a bunch of different CAD systems. Maybe I should write that down as a process and write a book about it. So I did. It's called Re-Use Your CAD, the Model-Based CAD Handbook. I wrote that and published it in 2013. And then people started saying, well, can you train me on this? So I said, okay. So I took the book and I started training people on what that meant to have model-based CAD and how you would reuse that CAD. And that grew into the business that Action Engineering is today, where we coach and we teach and we revise the Re-Use Your CAD handbook and re-release it with new concepts. And so we're kind of bringing vision along with a bunch of pragmatic how-to into one spot together so that people can be more resilient and hopefully reuse their CAD to their business value.
So this is interesting because, you go to one of the CAD tool vendors and we all know who they are. And, this group of people, we largely use the Siemens or Unigraphics tools, but
sure.
What you're commenting about is, well, how do you reuse your CAD? And I'm presuming from one tool set to another, right? It's not tool set specific. Are you able to exchange models? Is that part of what you're talking about?
Yeah, absolutely. It's all about data exchange. And then when we talk about the supply chain, like you mentioned in the intro, we are exchanging information about a product that you need to build. And so typically the engineering organization has to communicate somehow, preferably through math, that you stuff into a 3D model to the fabricators of what's acceptable to build. Is it okay if I have a 10 thousandths, 20 thousandths tolerance on this hole, or does it need to be super tight because you're pressing a bearing into it? What is that information and how is it used?
Okay. So then you've been doing action engineering for how long? It's a bit longer. It's not just recently.
It's not just recently. The company started in earnest in 2008. So we are working on 14 years of action engineering.
Okay. Well, good. So 2008 was that time frame where lots of changes occurred. The company I was with was briefly in bankruptcy and then came out.
Was kind of a funky time to start a business. Yeah, really funky time. I don't necessarily, it was us on that. It was time to get these ideas out of my head and bring to the world process-based ways of doing CAD. It
sounds very organic that your market was there, right? That people wanted help doing exactly this. They were tired of, if you will, reauthoring or redrawing or resketching, whatever their verb is there for how they put a model together in a CAD tool, and instead wanted to know how to keep reusing, even if you just use the design of a certain angle or a certain fillet, because that's the one that's structurally sound for the kind of mechanism you're building. So it's interesting. So in your overview that you and I have been discussing before the podcast here, I wanted to focus on supply chain.
Yeah.
In the car business, we were pretty confident or arrogant. We would just say, well, here's the CAD model format we want, and if you want to give us or sell us 100,000 parts or 1 million parts, you're going to use the same thing. And we never dealt with. Yeah, and this is what led to you guys, because Tier 1s probably came to you in the car business anyways and said, holy mackerel, Volkswagen wants it this way, General Motors wants it that way. Help us make sense of all this. So summarize for us the benefits that different organizations have by digitizing their supply chain with 3D models. So I'm talking about the chain now. What are the benefits we all get if we get that making happen? Yeah,
and I'm glad you brought up kind of the common practice 15 years ago was, here's our CATIA model. If you want to deal with us, you will also buy CATIA. And everybody went, well, that's a little pricey. So
especially if you're a small company.
Yeah. Are there some other options? And so about that time frame, the STEP format became very, very popular and was primarily used for geometry translation. And it's great. It's the most robust geometry translation we have to date. And there's a lot of what I call kind of third-party interoperability tools that translate between all these big CAD systems. And a lot of times they're using something like STEP, which is a neutral CAD file format, whereas the proprietary formats we tend to call native formats. So when we can exchange that geometry with confidence, hence the trust part, we need trusted models. When we exchange that information, the 3D geometry with confidence, then we don't have to remaster it. I don't have to take the 2D drawing that I get, that's typically on paper, although it's really a PDF that shows up on your screen today. If I take that and then recreate the 3D model out of that drawing, that's a lot of wasted effort. So we want to definitely eliminate that step.
And it's probably boring. It's not creative.
Also so boring. Yes.
It's just boring.
Also so boring. Yeah. And in fact, one of our favorite things to do when we coach people is we go, hey, here's the geometry. They go, yeah, but it doesn't have all my offsets that I need for manufacturing. We're like, great. Have you met direct modeling or hybrid modeling practices? Take this surface, offset it. Now you're good to go. And they're like, oh. So when you get to reuse that 3D data and use it in fun ways, like grabbing the model and then offsetting surfaces to create your manufacturing in process models, that's really fun. So across the supply chain, who's driving the transformation? Is it the end OEM or is it the supply chain? I could imagine it's all of the above, but I'm kind of curious. What do you see? Who's driving the hardest to make this really work? Well, it's an interesting question. So I had to put a little bit of thought into it. I think for automotive, and I'd be curious to get your opinion here, Craig. For automotive, we see that the OEMs are driving the change and making the requests of their tiered supply chain. And until or if they actually say, hey, supply chain, we want to get a 3D scan data of our measured end item part, and we want to get that back in 3D data because we want that feedback loop, it probably won't happen.
Right.
So that's one area we see. We see that the Department of Defense for aerospace and defense contractors are driving it and pushing it because they're requesting the data come from the models, and they're requesting that they get both native and neutral models delivered to them because they paid a lot of money for that data and they would like to have it.
Yeah, and that's our money they're using. But no, that's just a whole
good
nother
point. Excellent point. Spot on.
So yeah, I think the tier 2 and tier 3 suppliers I've talked to, and I haven't talked to a lot of them to be clear, they're kind of just overwhelmed by all this. And I think the more the OEMs, including aircraft manufacturers, which includes defense and commercial, the more they can be sensitive to that. The OEM should be able to get a price benefit, but they got to be sensitive to what the supply chain's asking for. And part of what they're asking for is just don't overwhelm me with requests. Don't make me go understand a complicated 3D model, especially if I'm only doing a little piece of the assembly, right? So interesting.
Right. And I think from the OEM's perspective, they're a little bit asking for unobtainium without
well, of course they always do.
Without providing them even a chemical formula for unobtainium. So I mean, our hope and part of our mission at Action Engineering is that we help uplift the workforce along the way and hopefully smooth down some of that overwhelming feeling because it is overwhelming.
I think another part of it is, especially at least for car companies, the prototype manufacturers, some of them, they're really skilled at what they do, but they may not be up to speed on the latest technology. And unless they've hired somebody in their 30s, they haven't taken the time, right? Because they didn't need to, because they're really good at building one-of-a-kind fixtures or a prototype vehicle or whatever. And so their business is quite successful without it. I think, and for those of you that are my age listening in, if you got to, well, go hire somebody who's really quite savvy with these tools. Maybe they've read books that Jennifer's written about how you reuse model stuff. But, once it is in a database and once you can exchange geometric dimensions between the different packages, all other kinds of avenues are going to open up. You mentioned the one about scanning a part coming off a line and provide me back that information into my quality system at the OEM, because I would love to know what the variation is of the parts coming off of the tier 1 or 2 or wherever it is in the supply chain.
Right.
Just to know, okay, am I going to deal with the tolerances? Okay, right. Your example of a bushing and bearing being put into something versus just a hole that we're going to weld or rivet, right? There's a difference in the tolerance there. They don't have to be as accurate depending on which one it is. So, yeah. So,
and
go ahead.
If I can add, so the additional information that you're getting in those feedback loops, once it's digital, you can now automate a lot of the analysis, which is when we really then start to elaborate on machine learning and AI concepts.
Oh, yeah.
So if you don't have that data and it's just you're just doing manual exchange of data and information along the chain, you don't have access to that information. And that's why that makes this kind of thing so important.
Well, and now that, AI and machine learning is really becoming a commodity. What I mean by that, everybody, is it's really affordable. Even the three of us could go off and try an experiment with Amazon services that is actually AI. So this is like, okay, cool. So now I can take advantage of it. Well, I got to take advantage of it, assuming I'm getting the measured data, right? And so everybody's got to be talking in a consistent set of orientation and geometry so that you can do that. Now, of course, quality departments, exactly.
Math, I'm just saying, math is important.
Quality departments are used to doing these sort of blind samples, right? Where they get 100 or in mass production, they get 1,000, and they try to figure out variation that way. This whole game changes if you can measure it in real time coming off the line, and then in the assembly process, if there's any other surprise, as in the case of a car, as it's moving down the line and installing all these sub-assemblies, it's just interesting what is possible now that you're interacting with this information coming directly from the manufacturing line. So it'll be fun to watch. And are you guys dabbling in the AI ML space, machine learning space? I mean, you're going to enable it. Thank you for doing what you're doing. Yeah,
I think we really focus on making sure that the data is good before it gets to that point. Because if you stuff in bad data into AI systems, then your result is bad. So we really focus on the
it's only doing pattern matching, everybody. It's not. It is. Maybe what we should. So
it's only as good as your data is.
It is artificial. That's why it's called artificial intelligence. But anyways, is there an industry or a set of companies that are leading the way, making sure this is happening for real? Because the benefits are clear. You get rid of the boredom. You'll be more efficient. Consumers will get better products. We'll get safer products. That's a good thing. Who's leading?
I'm going to go with aerospace and defense companies. Oh. And probably the reason for that is let me clarify. When you say aero, do you mean both commercial and military, or just the military side? I think both commercial and military. They both require a pretty strong audit trail. And traceability is one of the big messages we get out of model-based definition, because we've got 3D data, we can put unique identifiers on every characteristic, and we can trace that from design, manufacturing through inspection and back again. So again, that, creating feedback loops with traceable data, I think that's really where the big value is. I think that the automotive industry is poised to take advantage of some of the learning that aerospace and defense has ferreted out over the last 5 or 10 years around the quality inspection loop to engineering loop. And there's a lot of opportunity. I mean, we see savings numbers in the order of 80% time savings to program a coordinate measurement machine. I mean, that's a big number. Yeah, and if that happens, and it is the constraint at launch, oftentimes is those machines, getting them right so that you can run at your line rate, whatever that is. And so. And then, like you said, the in process is you start to build things, and you can take inspection points as you build and fabricate. That's a really big deal for managing your machine tools, making sure their equipment effectiveness is maximized over time. So if you've got these big machining centers, then you're running them 24/7, and maybe you're not today, you can make them even more effective. Yeah. There's a few people doing a really interesting research, mostly. Some are doing it for real in operations, but the predictive maintenance, right? Being able to tell that, oh, this is interesting. This machine all of a sudden isn't as fast as it used to be. And here's a vibration or thermal or even energy consumption, right? Electricity it consumes is now different. There's a clue, right? And to go schedule some preventative maintenance rather than waiting for it to break and then it'll be down longer, right? And then more you know about the engineering requirements of the part that's going through at that time, the better decisions you'll be able to make about whether you need to stop the production line or not. And so that's what's important about digitizing the tolerance information.
So you mentioned traceability. I think there's a couple forms of that. There's things like when it was built, which for sure in any well-managed quality system of a company, you know that, right? You can take apart your car, and as you look at plastic parts that were molded, or for that matter, metal parts too, you can find the day of the week. If you know how to decode the number, you can find the day of the week it was made on. So that's an interesting traceability, is knowing when. But another one that happened and is maybe a little disrupted this past year, but is knowing the raw material, knowing where it came from. You know, you do sampling to know the material properties. You specify the material you want, right? But the actual material you get might be a little different, especially if you build hundreds of things or millions of things. And so the traceability applies to that too. It's all this other metadata you can collect along the way that includes what was it made with, who made it, literally what operator made it. If you got, I hope you don't have that quality problem, but you might. Right? Maybe it's an unskilled laborer that made a mistake, right? So, well,
or if you focus it back on the supply chain, you may have 5 different suppliers producing a single part, and then you can look at the variation over supply chain.
Oh, yeah. And variation. Purchasing loves that because you know what they do.
Absolutely. Yeah.
The U4 are the best. The other one, not this time, right? And
that's right.
You know, so the award of business switches if you got enough volume to do that.
Right.
So there's, a lot of times, the history of engineering, we've come up with standards that let companies, in a way, it removes a competitive forefront, but on the other hand, it encourages more exchange, right? Are there standards here that help that help 3D model exchanges?
The short story is lots. How much time you got?
Well, wait a minute. Now, this came up earlier today in this conference I'm in. Why are there so many? Maybe you can answer that along the way.
Why are there so many? Well, I think the short story is there's lots of perspectives. And that's one thing that I've learned personally is there's lots of perspectives and ways to look at this data. So I'm an engineer, I design spacecraft, I design robots, to me, everything is a machined bracket. Clearly I have one perspective and there are more. Apparently, people don't not all the people in the world are engineers. In fact, there are probably not that many of us. I know.
We are a minority,
shocking. Whether
you like it or not.
I know. It's very odd to me. I'm like, wait, what? You don't think about this all day, every day? There are definitely other perspectives. And so we have a process at our company that we call Persona Palooza, and we take a look at an individual in the manufacturing organization, and we've identified about 50. So obviously we know who Tyler, the design engineer, is, but we've got to get deep under the skin of who Walter, the inspector, is, because sometimes he uses a tape measure to measure things, and if I'm building syringes or tiny little connectors, a tape measure is not going to cut it. Right. So and then we've got Mike, the manufacturing engineer, and Quintana, the quality engineer. So we've got all these different perspectives. So that could be part of it, Craig, is that every standard organization is coming at it from a little bit different perspective. The standards organizations that I am involved in are the Digital Metrology Standards Consortium, and that's the one that builds the quality information framework. Definitely coming from a metrology perspective.
Which is important, because we want to know the material properties, right?
Super important. They've taught me everything I know now about quality, because I didn't get that as a working engineer. I would just throw it over the wall. And so I had no idea how the parts were built. So that's a really big perspective shift for me. The next one that I'm involved in is ASME, American Society for Mechanical Engineers. There's the Y14 series of standards, which has geometric dimensioning and tolerancing. That's Y14.5, the most kind of well-known. Then there's Y1441 and Y1447 that deal with digital product data. Okay, we're now just looking at using the model only, and how do we transition? Yep.
So do these standards help purchasing do their job, or does purchasing just always go off and do a different thing? And what I'm getting at is the standards oftentimes come from engineers trying to solve exchange problems or knowledge transfer. But the whole contracting side of this,
yes,
too often goes back to a PDF file, right?
Yeah, we've worked with both commercial and military organizations, either in the contracting side and the government side. And it's an interesting point that you bring up. The way they use the standards in contracting and purchasing is go do your tolerancing per ASME Y145, go exchange the data per ISO 10303 step. Mm-hmm. So they're enumerating the standards so that they don't have to rewrite everything at every individual contract. So that using the standards in that way then brings the terminology and the common understanding.
That's a good thing, because that's part of what standards do, is just clean up the language, right? So that we talk consistently.
Yeah, they clean up the language, and for those of us who write standards, I mean, we really do have the mission of wanting it to be simpler for everybody, even though, believe me, writing standards is a very complex thing.
It's because it has politics, but never mind. That's a whole other. That's a whole other. That's right. It's a whole other podcast.
For sure.
There was one other thing in talking about 3D models and supply chains, and I like this phrase you guys use called circular connections. And can you expand on that? It sounds really intriguing. A circular connection with a 3D model. Describe that for us.
Well, there's a couple of things. There's the concept of a circular supply chain, meaning that instead of shipping material from one part of the world to another part of the world to manufacture it and then back to have it be put into service where it lives, you do it in a tighter pod and a tighter locale. Mm-hmm. So, maybe all of Denver, where I live, has these tight manufacturing cells where we're recycling the aluminum and we're turning it right into raw billets, so that then I can machine my space brackets out of it, right? And I build it all right there in house. And so if you kind of take that and extend it to what we're doing with model-based definition, it's again all about feedback loops. Okay. So if I author something in X, and then I take it to a supplier and they read in the geometry and they then build all their in-process models in SOLIDWORKS, but I've maintained characteristic traceability for each tolerance value, and then I inspect and measure and I tag it with each characteristic, then if I were really clever, I could be able to feed that back to the original model-based systems engineering requirements, and I have one characteristic that flows all the way through, and then we start to create these circular references where we're feeding back loop and we have more information than we've ever had.
Well, and I think that's what will make 3D models, I guess it's the name of your company, actionable, right? Because every now and then the light bulb goes on, but I think the point of our discussion has been really good. It's really important to the listeners. You've got to realize there are people like Jennifer solving this problem of flow of information across more than just one company or one department. And I think it is really important that we spend more time on this, not less time. So it's been really nice chatting with you. Some other day we'll call you back and talk about the pandemic. Maybe we'll be further past it by then. But right now I'll hand it back to Thom for a wrap-up.
So Jennifer, thank you so much for joining us here. If somebody wanted to learn more information about you or about Action Engineering, where can they find you?
Action-engineering.com.
That makes it simple. That's awesome. Action-engineering.com. Again, thank you for joining us here. And thank you to everybody who tuned in and listened. I say it every week. It's really about the audience, and that's why we do this show. But join us next week, because we're always going to be here with more thoughts, ideas, and information around product lifecycle management. And remember, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out right now at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.